Peenemünde, Baltic Coast, German Reich. Date, June 1944. Time, 02:15 a.m. The air above the dark, cold waters of the Baltic was thick with the scent of pine and something else, burnt propellant, ozone, and a terrifying, invisible promise. This was the silent, sterile birthplace of Armageddon. Below, in the heavily guarded complex of Peenemünde, the Reich's finest minds, men like Werner von Braun, had been wrestling physics and destiny into a terrible shape. They had been given a blank check from the Führer, a command to build weapons of such speed and destructive power that they could shatter the industrial might and morale of Britain and America, even as Allied boots were scraping the beaches of Normandy. The very landscape of the war in Europe had been defined by scale, the brutal, unyielding arithmetic of Allied production. By 1944, Britain and the United States were churning out war material with a relentless, terrifying efficiency. Every day the skies over the Reich were darkened by formations of B-17 flying fortresses and Lancaster bombers, protected by the burgeoning fleet of P-51 Mustangs. This overwhelming scale had stripped Germany of its primary strategic advantage: surprise. Their vaunted blitzkrieg had devolved into a defensive, attritional grind. Yet there was one desperate answer, a technological Hail Mary that promised to bypass the industrial output, the fighter screens, and the vast, slow assembly lines of the enemy. It was a weapon that didn't need a pilot, didn't need air superiority, and didn't need to cross the English Channel at a vulnerable 20,000 feet. It needed only a trajectory and a powerful imagination. Irony of destiny. By late 1943, Allied intelligence knew something massive was being built along the coast. They saw the concrete pads, the rail lines, the strange, squat buildings. They launched Operation Crossbow, a grueling campaign of precision bombing, but the target was moving, changing, and hiding its ultimate shape. What the Allied commanders did not yet grasp, what kept them tossing in the night, was the philosophical difference of this new threat. They were prepared for bigger bombs, faster planes, even chemical warfare. They were not prepared for an enemy that defied the speed of sound and arrived without warning. The true fear of the Allies was not the German soldier or the U-boat. It was the German engineer and the boundless ambition of his laboratory. From the Allied side, the reports arriving on the desk of Prime Minister Churchill were almost unbelievable. Colonel Duncan Sandys, tasked with investigating the matter, was met with incredulity by his peers. How could a rocket, traveling faster than the sound of its own engine, be intercepted? The challenge was not military, it was existential. They laughed when I showed them the reconnaissance photos. They called it Hitler's last doodle. But the sheer size of the concrete emplacements, the orientation towards London, it told a different story. This was not a bluff. This was the final, terrible endgame of science divorced from morality. Colonel Duncan Sandys attributed historical sentiment. This was the core contradiction of the Reich. Even as its armies were pushed back on the Eastern Front and its cities turned to dust on the West, its technological leap was accelerating. The resource allocation was staggering. Steel, fuel, specialized labor, all were diverted to this single desperate project. The focus was now on the final product, the A4, soon to be designated the Vergeltungswaffe II, V2. At first, the German pilots and ground crews felt a surge of renewed hope. The skies were lost, but this was a weapon launched from the ground, beyond the reach of the mighty P-47 or the Spitfire. It represented a fundamental shift from a war of attrition to a war of absolute, inescapable terror. The design was elegant in its brutality. A single-stage, liquid propellant rocket using liquid oxygen and an alcohol-water mix. It was a fusion of ancient Chinese fireworks and the most advanced concepts of 20th century physics. It weighed 5 metric tons at launch, carrying a warhead of nearly 1 ton of Amatol high explosive. But the most terrifying number was its speed, reaching a maximum velocity of over 3,500 mph, 5,600 km/h, and hitting the ground at 3 times the speed of sound, Mach 3. It was a missile from the future, rendering obsolete every existing defense mechanism, radar, anti-aircraft guns, even the interceptor fighter. The irony was that the rocket, designed to be the ultimate expression of Aryan superiority and German ingenuity, was being built under the most horrific conditions imaginable. Deep beneath the Harz Mountains, in the subterranean tunnels of Mittelwerk, thousands of slave laborers, political prisoners, Jews, captured soldiers, were assembling the future weapon of terror. The air in the tunnels was stale, the silence broken only by the clang of metal and the muffled cries of the dying. The engineers, protected by their white coats and their specialized knowledge, tried to ignore the human cost, focusing only on the tolerance of the gyroscope and the perfect mixture of the fuel. The stage was set. Germany, facing inevitable collapse through conventional means, was about to unleash a technological storm. The question was no longer if the Allies would win, but what price they would pay to stop this silent, unstoppable tide of terror. The true fear lay in the knowledge that one day, any minute, without the wail of a siren, the shadow of a rocket would fall upon a civilian street. The story of the V2 is a story of technology, terror, and the fine line between genius and madness. To follow the full history, from the silent labs of Peenemünde to the streets of London, make sure to subscribe and turn on notifications so you don't miss the next chapter of this deep dive into the turning points of WWII. Location: London, England. Date: September 8, 1944. Time: 6:43 p.m. The evening was crisp, with the relief of a late summer sunset after years of grinding war. Londoners, hardened by the Blitz, had learned to live by the rhythm of the air raid siren, the deep thrum of incoming bombers, and the sharp bark of the 80mm flak batteries. Danger was loud. Danger gave you precious seconds to find cover, but on this September evening, a new sound, or rather, the lack of sound, redefined terror. In a quiet suburban street in Chiswick, a massive explosion ripped through the homes, incinerating everything within a 100-foot radius. It was a profound, concentrated act of violence, yet there had been no warning. No drone of engines, no scream of a descending bomb. A German pilot, Flight Lieutenant Erich Witzke, based near The Hague, described the operation. "We had failed to break England with the Luftwaffe. Now we were giving the English a new kind of fright. We weren't pilots, we were button pushers. We would receive the coordinates, aim the massive device, and launch. The beauty of the rocket was its indifference. It didn't care about weather or clouds or Spitfires. It simply went up, beyond the atmosphere, and came down with a vengeance. Our engineers told us the English wouldn't hear it until it was already too late. That, they said, was the point of the V2. Based on historical sentiment of V2 crew, the Allies named it the Ghost. The V2 program was strategically brilliant in its simplicity. It was designed not just to destroy buildings, but to destroy the siren. The suddenness of the attack, the zero warning impact, bypassed the entire civil defense apparatus built up over 5 years. The psychological effect was immediate and devastating. You could live through a bombing raid by taking cover. You could not live through a V2, because the only way to know one was coming was by the catastrophic force of its arrival. The technical challenge for the Allies was unprecedented. Conventional radar systems were tuned to detect slow-moving, metal-bodied aircraft. The V2, reaching altitudes of 55 miles, 88 kilometers, the edge of space, and descending vertically at Mach 3, was simply too fast for early warning. By the time a radar system did detect the projectile, it was already minutes away from impact, giving negligible time for warning, let alone interception. British scientists and mathematicians, working in secret at the Telecommunications Research Establishment, TRE, threw themselves at the problem. They were trying to track a ballistic projectile that moved with the precision of celestial mechanics, but they only had World War II technology. Their solution became known as the Big Ben experiment, named after the code word for V2 attacks. It involved a network of 3 specialized radar stations spread across the southeast of England: the Microwave Early Warning, MEW, and Chain Home Low, CHL systems. The goal was not to intercept, but to predict the landing site with enough accuracy, within a few miles, to allow ambulances and rescue services to be deployed immediately. The true breakthrough came from the realization that while they couldn't see the rocket falling, they could see its engine burn shortly after launch from the Netherlands, where the mobile V2 units were now deployed. The V2's liquid fuel engine burned for a mere 60 to 70 seconds before cutoff, accelerating the missile to its apogee. This brief, fiery trace was the only signature they could track. The scale of the German effort was relentless. From September 1944 to March 1945, Germany launched over 3,000 V-2 rockets in total, with more than 1,400 aimed directly at London and Antwerp, the key supply port for Allied forces fighting in Western Europe. A corporal in the London Fire Brigade, working the night shifts, recalled the shift in atmosphere. With the normal bombs, you could hate the man who dropped it. You'd shake your fist at the sky. But with these rockets, there was nothing to hate but the air itself. It was the most lonely total death. You'd be drinking tea and the next second your block was gone. It felt less like war and more like an impossible geological event. It broke your spirit because it took away the only thing a soldier or a civilian has, the chance to fight back. Composite quote based on London accounts. The German High Command was obsessed with maximizing this psychological pressure. Every successful launch was seen as a victory against the Allied will to fight. They truly believed that if they could maintain a high-tempo bombardment, disrupting the supply chain through Antwerp and shattering London's morale, they could force a negotiated peace before the inevitable ground invasion of Germany. This weapon was their only viable path to victory. But the V-2 was not without its flaws. The engineering tolerances were extremely tight, leading to a high failure rate. Up to 50% of the early rockets either exploded on the pad or broke up during atmospheric re-entry due to structural or guidance failures. The ultimate irony, however, was in the weapon's guidance system. The V-2 used a simple inertial guidance system, relying on 2 gyroscopes and an integrating accelerometer to cut the engine thrust at a precise velocity needed to reach the target. While a marvel of engineering, its final accuracy was still measured in miles, not feet. It was a strategic weapon, terrifyingly accurate against a vast city, but tactically imprecise against a military target like a dock or a specific factory. The German High Command desperately needed it to be a strategic game-changer. The Allies desperately needed to find a way to make it collapse overnight. The fate of the entire war hung on the next act, a secret war of intelligence, sabotage, and hunting down the ghost launchers. The scale of the V-2 attacks demanded a military response, but how do you fight a weapon you cannot see and cannot shoot down? The answer was a complex, multi-layered campaign of intelligence, sabotage, and strategic bombing, the hunting of the hounds. The most critical realization for the Allies was that the V-2 was not a silo-based weapon. The immense concrete bunkers initially targeted by Operation Crossbow were either decoys or were rendered irrelevant by the German decision to use mobile launching batteries, Milewagen. This was a stroke of genius, turning a fixed weapon into a ghost that could hide in the forests of the Netherlands and Belgium. The Allied counter-strategy had 3 main pillars. 1. Technical deception. This was the most audacious element. British intelligence, through the double-cross system, XEX system, began feeding misinformation back to the German Launch Command. The V-2's guidance system, while a wonder, was prone to slight errors. By carefully analyzing the mean point of impact of the rockets that hit London, many fell short of the primary targets like Westminster and the docks. The British deduced that the German telemetry system was calculating its aiming based on a false mean. What was the Allied response? They used double agents to subtly imply, through verified spy reports, that the rockets were overshooting their targets. The German command, aiming for central London, thus began adjusting their trajectory to fall shorter, aiming at the less densely populated south and east suburbs. This deliberate deflection, confirmed by historical analysis, saved thousands of lives in the densely populated city of London. It was a victory of psychology over physics. 2. Air reconnaissance and pinpoint hunting. The 2nd Tactical Air Force, TUTAF, was tasked with finding and destroying the launch batteries, Batteriefeuerstellung. This was a painstaking, deadly task. The German procedure was highly disciplined. The unit would arrive at a secluded location, often a wood or the cover of a viaduct, under the cover of darkness, erect the missile on the Milewagen, fuel it, fire it, and disperse within hours. The time from arrival to launch was only about 6 hours. The TUTAF pilots, flying low-altitude, high-speed reconnaissance missions in Spitfires and Mosquitoes, were not looking for massive structures. They were looking for tiny, telltale signs. The fresh tire tracks leading into a copse of trees, the specific configuration of support vehicles, or the unmistakable scorch mark left on the asphalt after a launch. You'd fly over the Hague area, and it was like hunting smoke. You knew they were there, hiding in the trees like snakes. Sometimes you'd see a single long fuel truck, or maybe just the outline of a field phone connection. The German discipline was terrifying. We didn't destroy many rockets, but every time we forced them to move, every hour we delayed a launch, we won. Captain David Miller, 2 TAF recon pilot. Composite quote. 3. The sabotage from within, Mittelwerk. The ultimate vulnerability lay in the V2's industrial berth. Deep in the subterranean tunnels of the Mittelwerk factory, thousands of prisoners, under the most brutal conditions, were assembling the core components. This was the theater of human resistance. Prisoners, motivated by an incredible, quiet courage, found ways to commit sabotage. They would urinate into the sensitive gasket seals, loosen critical bolts that would only fail under the intense vibration of launch, or replace vital wires with mismatched inferior parts. An anonymous former Mittelwerk prisoner, forced to work on the control mechanisms, recalled the terror and the determination. They gave us the components, and they watched us. But a human eye cannot see every single gesture. I learned which wire was the most vital for the gyroscope. I would carefully nick the insulation, just enough so that when the great machine climbed to the limits of the atmosphere, the pressure would cause a short. The thought that my ruined connection might save a life in London was the only thing that made the cold and the hunger bearable. For every rocket that exploded mid-air, 100 of my comrades paid the price in the tunnels. Translated and paraphrased from historical accounts of Mittelwerk prisoners, these subtle acts of defiance contributed significantly to the high failure rate of the V2 program. It was a battle fought in silence miles beneath the surface, where the enemy was not a tank, but a simple, deliberately placed piece of dust or a poorly soldered connection. The combined effect of these 3 strategies, deception, relentless air harassment, and internal sabotage, began to place an unbearable strain on the German V2 operation. They had their unstoppable weapon, but the logistics and the human factor were the weak links the Allies were relentlessly exploiting. The collapse was being orchestrated not by a single dramatic battle, but by 1,000 precise invisible actions. Location: Western Front, autumn-winter, 1944-1945. Focus: the diversion of resources and the final statistical reckoning. The problem with a technological wonder, when you are losing a total war, is the scale of the commitment it demands. The V2, intended as a shortcut to victory, became instead a bottomless drain that accelerated the collapse of the Third Reich. This was the engine of futility. By late 1944, as Allied armies pushed across France and the Soviet Red Army began its inexorable sweep westward, the German war machine faced a critical shortage of 3 things: skilled labor, fuel, and transport capacity. The V2 program required a staggering diversion of these resources. Skilled labor. The rocket needed specialized technicians, mathematicians, and engineers who could have been designing or building vital conventional war machines such as the advanced Jagdpanther tank destroyers or the Me-262 jet fighter, weapons that could have directly contested Allied air and ground superiority. Over 40,000 workers were ultimately involved in the V2 program. Raw materials. Each V2 consumed vast quantities of strategic materials: high-grade aluminum for the casing, high-purity liquid oxygen, LOX, and alcohol for the propellant. The steel alone diverted could have manufactured thousands of conventional artillery pieces or hundreds of panzer tanks. Transport. The logistics of the mobile launch batteries were a nightmare. V2 components, fuel, and the massive Milewagen had to be moved across a rail network, increasingly shattered by Allied bombing. Every trainload of V2 fuel was a trainload of vital ammunition or food that did not reach the beleaguered Wehrmacht troops on the front lines. The statistical analysis after the war revealed the astonishing cost-benefit ratio, or lack thereof, of the V-weapon program. The total cost of developing, manufacturing, and launching the V2s was estimated to be equivalent to the cost of producing approximately 10,000 conventional heavy bombers. The number of lives lost to V2 strikes was tragic. around 9,000 civilian and military deaths in Britain and the continent, but this paled in comparison to the strategic losses inflicted by 10,000 operational bombers, which could have obliterated German industry. General Albert Speer, the Minister of Armaments, later reflected on the V weapons. From the point of view of the German war economy, the V weapons were a failure. They did not shorten the war by a minute. The effort poured into them was one of the greatest technological wastes of history. The war would have been far more effectively prosecuted with the resources diverted to these instruments of terror. Paraphrased from Speer's post-war testimony, the strategic failure lay in the fact that the V2 was an instrument of terror, not of tactical victory. It could not destroy a factory, a bridge, or a concentration of troops with reliable precision. It could only kill randomly and generate fear. Meanwhile, on the Western Front, the German troops were paying the real price for this technological vanity. The famed panzer divisions were running desperately low on fuel. Their tanks, superior in many ways to their Allied counterparts, often immobilized for lack of gasoline. Yet, the trains carrying the specific high-purity alcohol fuel for the V2s continued to roll towards the launch sites. This strategic misallocation led directly to the failure of Germany's last great offensive, the Battle of the Bulge in December 1944. The offensive stalled not just due to Allied resistance, but due to a catastrophic lack of fuel to sustain the rapid advance of the spearhead panzer divisions. The irony here is brutal and absolute. The weapon designed to win the war for Germany was simultaneously starving its conventional forces to death. The Allies, sensing this final desperate move, concentrated their own resources. British and American codebreakers were constantly monitoring the German communications related to V-weapon launch coordination. When a concentration of V2 activity was noted near a specific area of the Netherlands, the Allied High Command would immediately respond, not just with bombing, but with a massive push in that sector to dislodge the mobile batteries. The relentless pressure, the precision bombing of fuel depots, especially the LOX production facilities, and the quiet efficiency of Allied intelligence meant that the average launch tempo, while terrifyingly high, was never enough to break Allied morale or significantly disrupt the flow of supplies through Antwerp. The fear, which had been so palpable in September 1944, began to recede, replaced by a grim determination. The Allies realized the ghost in the sky was not unstoppable. It was merely the dying breath of a technological tyranny that had gambled its very future on a single, unsustainable rocket. The clock was running out on Germany's final strategic card. Location: Wassenaar, The Hague, Netherlands. Date: March 27, 1945. Focus: the final launch and the spoils of war. The final act of the V2 terror on London came not with a bang, but with a sudden, deafening silence. On March 27, 1945, near the small Dutch town of Wassenaar, the last V2 aimed at London was launched by Battery 500. The missile lifted off, climbed its apogee, and impacted a house in Orpington, Kent, killing a single woman. And then there were none. The collapse was sudden and complete. It was not a grand surrender, but a logistical breakdown. Allied forces, finally pushing the German lines back in the Netherlands, had simply overrun the mobile launch areas. The German units, out of fuel, out of transport, and under constant harassment, could no longer bring the alcohol and LOX to the launch sites. The technological terror was defeated not by a miraculous defense system, but by the relentless grinding reality of being pushed out of range. The irony of the V2 was that it was a weapon before its time. It had failed to win World War II, but it had irrevocably changed the nature of future conflict. It was the bridge between propeller planes and the coming Cold War missile age. As the war ended, a new, intense race began, the race to capture the German scientists, the designs, and the technology that had created the V2. The ultimate spoils of war were not gold or territory, but knowledge. Both the Americans and the Soviets launched aggressive operations to seize the V2 production base at Mittelwerk and the research teams. The Americans led the charge with Operation Paperclip, securing Werner von Braun and over 100 of his key rocketry experts. The scientists were transported, along with entire V2 missiles, to the United States. The Soviets secured the V2 factory equipment and the remaining documentation, transporting it all back to the USSR. The very technology designed to win the war for Hitler became the foundation of the post-war superpower arms race. The rockets that would later place satellites into orbit and men on the moon were direct descendants of the V-2. The Saturn V that launched the Apollo missions was conceptually traced back to von Braun's drawings in Peenemünde. The true legacy of the V-2, beyond the trauma inflicted on London and Antwerp, is a terrifying realization that the absolute power of technology is politically neutral. It is a testament to the fact that even the most desperate, technologically advanced military effort cannot survive the failure of logistics, strategy, and human morality. The ultimate lesson of the ghost in the sky is that a weapon of terror can shatter buildings, but it cannot shatter the will of a people hardened by total war, especially when that will is backed by overwhelming industrial might and an unyielding commitment to precision and intelligence. Germany's only way to win WWII collapsed overnight, not because the rocket was technically flawed, but because the war effort supporting it was unsustainable, starved by its own technological ambition. The fear that gripped the Allies in 1944 was real, but the strategic breakdown orchestrated by their intelligence, their relentless air pressure, and the courage of the prisoners in the dark tunnels proved that the human element, in resistance and strategy, was the only force capable of defeating a machine that moved at Mach 3. It was the end of one war and the immediate terrifying start of the next. The story of WWII is filled with these hidden technological battles. If you want to dive deeper into the strategic miscalculations, the dark science, and the personal heroism that defined the war, make sure to like this video, leave a comment telling us which untold story we should cover next, and subscribe to join our deep dive history community. We'll see you in the next chapter of history.